Nth roots and rational exponents, part 2. So we're on example 3, and it says approximating expressions with rational exponents. So we need to evaluate each expression using technology, round your answer to 2 decimal places. So this time it wants us to use our calculators. So A part says 9 to the 1/5 power. So we're going to do 9 raised to the 1/5 power. Well, I forgot to divide here. Let's see. So divide by, all right, now it says 9 to the 1/5 power, and then hit enter. And it says 2 decimal places, so 1.55, because this number is lower than 5, this stays the same. So I'm going to have about 1.55. B part says 12 to the 3/8, so I've got 12 raised to 3 divided by 8 is my 3/8 power, and hit enter. This is 2.539. The 9 is greater than 5, so that means this 3 goes up to a 4. So about 2.54. All right, so we have one last one for fourth root. All right, I had that typed incorrectly a second ago, but this is a fourth root of 7 cubed. So the first thing we need to do, this is in radical form, we need to write this in exponential form. So we can rewrite that as 7 to the 3/4 power. So 7 to the 3/4 power. This is already the power. This is the index, so it becomes the denominator of this fraction. And then we can put that in our calculator as well. So 7 to the 3/4 power and that's going to be about 4.30. Again, because it says 2 decimal places, that's why we added the 0 on the end, even though it doesn't make a difference. Example 4, solving equations using nth roots. Find the real roots. Round your answer to 2 decimal places if necessary. So we're going to be rounding again. All right, so A part says 4x to the 5th power equals 128. So the first thing we need to do is get our variable by itself. So we're going to divide both sides by 4. So we're going to have x to the 5th power equals 4 goes into 128. So 4 goes into 12 3 times. And 4 goes into 8 twice. So that becomes 32. And we need to undo something to the 5th power. So we need to raise that to the 1/5 power, which is the same thing as taking the 5th root of that side. So if we take the 5th root of 32, the 5th root of 32 we learned a few minutes ago in the previous video, 2 to the 5th power is 32, so the 5th root of 32 is just 2. And that would be your solution. So x equals 2 is the answer to A part. All right, B part has a quantity, x minus 3 raised to the 4th power equals 21. Since that's in parentheses, that means we have to take the whole thing to the 4th root, or to the 1/4 power if you prefer to do that. So we're going to do the 4th root of x minus 3 to the 4th equals 21. Again, the 4th root and the 4th power cancel, so it leaves x minus 3. And we have to do the same thing to the other side. So we're going to do the 4th root of 21. And then after that, we simply add 3 to both sides. So we're going to have x equals 3. And we know it's a 4th root, so it's going to be plus or minus the 4th root of 21. And I'm going to leave it like that. That's probably going to be like an irrational number, because there's no number that goes into 21 evenly. It's going to be 21 is 3 times 7 or 1 times 21, but there's no power of any number that's going to produce this right here. So if we want to round to decimal places, we've got two answers here, 3 plus the fourth root of 21 and 3 minus the fourth root of 21. So let's go ahead and see what those are. So I'm going to have 3 plus, and then the fourth root. I've got to do 4 and find my x root power. Okay, so that makes that your index, and then 21. And we're trying to round to 2 decimal places, so this is going to be our first answer. So that's going to be about 514. And then we're going to do the same thing, except now we've got a negative. So we're going to have 3 minus, and then we're going to do 4 to the x root, so the fourth root of 21. And again, it's going to change the answer because that is a negative fourth root of 21. So our second answer is about 0.86. Again, this 9 here makes that 5 round up, so about 0.86. So that would be your answers rounded to 2 decimal places. Now your principal root, both of those are positive, so both of those are actual solutions here. All right, again, common error. A lot of students forget that this plus or minus means there are 2 answers. So remember, when n is even, that's your index here of 4. When n is even and a is greater than 0, make sure you consider both your positive and negative nth roots. Example 5, modeling real life. A hospital purchases an ultrasound machine for $50,000. The hospital expects the useful life of the machine to be 10 years, at which time its value will have depreciated to $8,000. The hospital uses the declining balances method for depreciation. So the annual depreciation rate R in decimal form is given by the formula R equals 1 minus S divided by C raised to the 1 over n power. In the formula, n is the useful life of the item in years. So the useful life of the machine was 10 years. So we know that's going to be our n. S is the salvage value in dollars. So S would be the value was at $8,000. So that's going to be your S value. And then C is the original cost. So the original cost, the hospital purchased an ultrasound machine for $50,000. That was the original cost. What annual depreciation rate, so that's going to be a percentage, what annual, that's yearly, what annual depreciation rate did the hospital use? All right, so let's look at our formula and plug in what we know. So we're looking for R. That's going to equal 1 minus. And then we said C, that's the salvage amount. That's how much they can sell it for at the end of 10 years. That's going to be $8,000 over the original cost, which was $50,000. And then 1 over N. And remember, N is the useful life in years. And it says that the useful life of the machine would be 10 years. So that's 1 over 10. So now we just have to look at what we have and reduce. So 8,000 divided by 50,000, we can mark off a few of these zeros here. And then 8 divided by 50, we could reduce both those by 2 if we want. All right, 2 goes into 8 4 times. 2 goes into 50 25 times. So we can reduce that to a smaller fraction, and that's raised to the 1/10 power. So what we can do at this point is just type it in our calculator and see what we get. So the reason we start with 1, this is like, remember when we did interest and stuff before, 1 is the whole amount. If we multiply 1 times 50,000, you get 50,000. what we're doing is depreciating this. We're trying to figure out what the interest rate is after, say, 10 years. So let's type this in, and we got 1 minus, and then we're going to have 4 divided by 25, and that's going to be raised to the 1/10 power. And this is going to give us a decimal. So it's going to give us 0.167. So it says, so the annual depreciation rate in decimal form is given. Then it says, what annual depreciation rate did the hospital use? So we can say this is about 16.7%. All right, so the annual depreciation rate is about 0.167. As a percent, that would be 16.7%. All right, that's all for this lesson. If you have any questions, let me know.